Next question is, prove that the function f of x is equal to x raised to n is continuous at x is equal to n, where n is a positive integer. Here n is a positive integer, means n is a natural number. Okay, so here given function is f of x is equal to x raised to n, right? So we have to prove this function is continuous at x is equal to n. See, by the definition of the continuous function, we have to find limit x tends to n f of x is equal to limit x tends to n f of x is x raised to n. Here substitute x is equal to 1, we will get n raised to n. See, if n is any positive value, this value will be a finite number. Okay, that is, see, if n is equal to 2, it will be 2 raised to 2, right? So here if we substitute n is equal to n, we will get n raised to n. Okay, it's a finite number. So next we have to find value of the function. Okay, according to the definition of the continuous function, we have to prove, for continuous function we have to prove limit x tends to n f of x is equal to f of n, right? So what is the value of the function f of n? F of x is equal to this one, so f of n is nothing but n raised to n. Okay, see here n belongs to n. Okay, n is a natural number. So here we have got f of n is equal to n, and limit x tends to n f of x is equal to n raised to n. So we write limit x tends to n f of x is equal to f of n. Hence given function is f of x is equal to x raised to n is continuous at x is equal to n. Okay, that's all. Is the function f defined by f of x is equal to x if x less than or equal to 1, f of x is equal to 5 if x greater than 1, continuous at x is equal to 0, x is equal to 1 and x is equal to 2. So here we have to check whether given function is continuous at x is equal to 0, at x is equal to 1 and x is equal to 2 or not. Okay, so first of all let's consider at x is equal to 0. So here x is equal to 0, here need not to find check left hand limit and right hand limit of the function at x is equal to 0, because here the conditions is x less than 1. Okay, x less than or equal to 1, x greater than 1. So here let's find the limit x tends to 0 f of x. Okay, so let's check whether it exists or not. Okay, so here limit x tends to 0 f of x is equal to limit x tends to 0. See, when limit x tends to 0 means x approaching to 0, right? Means x is very close to 0. Okay, that is x is very close to 0 means it is less than 1, right? X less than 1. So what is the function? X, right? So when x tends to 0 means it is very close to 0, that is less than 1. So therefore the function is x. So here substitute x is equal to 0, you will get 0. Okay, next let's find here, first of all we are checking whether this function is continuous at x is equal to 0 or not. Okay, so for that, according to the definition of the continuous function, we need to find f of 0, value of the function. So f of 0 is equal to f of x is equal to x, right? When x is equal to 0, when x is 0, the function is x. Okay, so here f of 0 is nothing but 0. Okay, why? Because f of x is equal to x when x is equal to 0. Okay, here when x is less than or equal to 1, the function is f of x is equal to x. Okay, so f of 0 is equal to 0. So here we have got limit x tends to 0 f of x is equal to f of 0. Therefore we can say this function is continuous at x is equal to 0. Therefore f of x is continuous at x is equal to 0. Okay, next we have to check this function at x is equal to 1. Okay, continuous function at x is equal to 1. So for that, see here we need to check left hand limit and right hand limit of the function. Because see our conditions x less than 1, x greater than 1. Right? So here we need to find the left hand limit and right hand limit of the function. Okay, so limit x tends to 1 minus. X tends to 1 minus. X, the value of x is close to 1 and it is less than 1. Okay, it is very close to 1 and it is less than 1. F of x is equal to limit x tends to 1 minus. So here what is the function f of x? When x less than 1, x is very close to 1 and it is less than 1. See, when x less than 1, the function is x. That is equal to, now substitute x is equal to 1. Okay, it is not minus 1. 1 minus means left of 1. Okay, less than 1. Suppose it is a real line. It is the point to 1. Okay, left of 1 minus means the points very close to 1 and it is less than 1. Okay. So here substitute x is equal to 1, we will get 1. Okay, next is right hand limit. Limit x tends to 1 plus f of x, that is equal to limit x tends to 1 plus f of x. 1 plus means the x value of x is very close to 1 and it is greater than 1. Okay, that is when x is greater than 1, the function is 5. Okay. So when we substitute here, see here there is no variable, so only constant, so 5 itself. Limit of this function is 5. Okay, so here we have got, see, left hand limit is 1, right hand limit is 5. They are not equal, right? So here, therefore limit x tends to 1, f of x does not exist here. Hence this function is not continuous at x is equal to 1. Okay. Here limit x tends to 1 minus f of x not equal to limit x tends to 1 plus f of x. Therefore limit x tends to 1 f of x does not exist. Does not exist. Okay. Hence this function is, hence f of x is not continuous at x is equal to 5. Now what about third one? Sorry, not x. At x is equal to 1. Okay, at x is equal to 1. F of x is not continuous at x is equal to 1. So what about third one? X is equal to 2. See here also no need to find left hand limit and right hand limit. Our conditions x less than or equal to 1, x greater than 1. So directly we can find limit x tends to 2 f of x. Okay. So limit x tends to 2 f of x. Limit x tends to 2 f of x, that is equal to x tends to 2 means the value of x is it is very close to 2 and greater than 1, right? See, when x is greater than 1, the value of function is 5. Okay. So limit x tends to 2, f of x is 5. So the value limit of this function is 5. Okay. Next, we have to find the f of 2. Okay. F of 2. What is f of 2? When is f of 2? When x is equal to 2, right? So when x is equal to 2, x is equal to 2 means x greater than 1. Okay. It is greater than 1. Therefore, the function is 5. Okay. So our function is f of x is equal to 5 when x is equal to 2. Right. So when if f of x is equal to 5, then what is f of 2? 5 itself, right? Because it's a constant function. So f of 2 is also 5. So here we have got limit x tends to 2, f of x is equal to f of 2. Hence the given function is continuous at x is equal to 2. Limit x tends to 2, f of x is equal to f of 2. Therefore f of x is continuous function at x is equal to 2. Find all the points of discontinuity of f where f is defined by f of x is equal to 2x plus 3 if x less than or equal to 2, f of x is equal to 2x minus 3 if x greater than 2. See, here we have to find at which points the function is not continuous, okay, or the function is discontinuous. So, the function is f of x is equal to 2x plus 3 if x less than or equal to 2, f of x is equal to 2x minus 3 if x greater than 2. See, for x less than 2 and x greater than 2, these functions, this function is polynomial function, right? See, when x less than 2, function is 2x plus 3, it is a polynomial function of degree 1. And when x greater than 2, this function 2x minus 3 is also a polynomial function of degree 1, right? And we have polynomial function is a continuous function, right? Therefore, here we can write for x less than 2 and x greater than 2, f of x is a polynomial function and it is continuous, okay? And it is continuous. Here we have to check whether this function is continuous at x is equal to 2. Okay, individually we have to check this function is continuous at x is equal to 2 or not. So here let's find. See, our conditions are x less than or equal to 2, x greater than 2. So we need to check left hand limit and right hand limit of the function. So limit x tends to 2 minus f of x is equal to, that is limit x tends to 2 minus the value of x is very close to 2 and less than 2, okay, f of x here less than 2, so the function f of x is equal to 2x plus 3, that is equal to, substitute x is equal to 2, okay, don't substitute x is equal to minus 2, it is not minus 2, 2 minus means it is less than 2, very close to 2 and less than 2, okay. So 2x plus 3, 2 into 2, 4, 4 plus 3, 7. Next, let's find right hand limit. Limit x tends to 2 plus f of x. That is, x value is close to 2 and greater than 2. Okay. So the function is, when x greater than 2, the function is 2x minus 3. Limit x tends to 2 plus f of x is equal to 2x minus 3. Now substitute x is equal to 2. 2 into 2, 4. 4 minus 3 is 1. Okay, see here. What we have got? Left hand limit is 7. Right hand limit is 1. Therefore, here left hand limit not equal to right hand limit. Hence, limit x tends to 2. F of x does not exist. Therefore, this function is not continuous at x is equal to 2. That's our question. See. Find all the points. At which point the function is discontinuous. So here at x is equal to 2, the function is discontinuous. Okay. So we can write here limit x tends to 2 minus f of x not equal to limit x tends to 2 plus f of x. Therefore, limit x tends to 2 f of x does not exist. Hence, f of x is not continuous or discontinuous. Is discontinuous at x is equal to 2. It is the answer. At x is equal to 2, the given function is discontinuous. Find all points of discontinuity of f where f is defined by f of x is equal to modulus x plus 3 if x less than or equal to minus 3. Minus 2x if minus 3 less than x less than 3. F of x is equal to 6x plus 2 if x greater than 3. See here, see our function is for x less than minus 3. For x less than minus 3, what is our function? Modulus x plus 3. See, here we know that modulus x can be defined as minus x when x less than 0, right? X less than 0 means when x is negative values, the function is minus x, right? Modulus x is equal to minus x. So here similarly, here x less than minus 3 means all the values of x are minus, right? So minus values. So here we can write this modulus x will be minus. Okay, so it will be minus x plus 3. Okay, because modulus x function is modulus x is equal to minus x when x less than 0. X less than 0 means x values are negative values. Okay, so in that case f of x is equal to minus x means modulus x is equal to minus x. So here also when x less than minus 3, here the modulus x is minus x because minus x less than minus 3, x values are negative values. Okay, so it will be minus x plus 3. F of x is equal to minus x plus 3. And for minus 3, x minus 3 less than x less than 3, that is when x belongs to minus 3 to 3, or you can write this itself, x belongs to minus 3 to 3. Minus 3, x values between minus 3 and 3. That is nothing but open interval minus 3 to 3. Right? So what is the function? F of x is equal to minus 2x. And for x greater than 3, function f of x is equal to 6x plus 2. Right? Okay. Now here, see, all these functions are polynomial functions. So we can say when x less than minus 3, for x less than minus 3, for x belongs to minus 3 to 3, okay, and for x greater than 3, the function is polynomial function and it is continuous. Now here we have to check the only one point at x is equal to 3 whether this function is continuous or not. Okay, so we can write for x less than minus 3, okay, x belongs to minus 3 to 3, and for x greater than 3, for the function f of x is polynomial and it is continuous. It is continuous. Okay. Now we have to check at x is equal to 3, the function is continuous or not. So for that, here the conditions are x less than or equal to minus 3, x greater than 3, right? So let's find, see, here x less than minus 3, we have to check is x is equal to minus 3 and x is equal to 3, okay? At x is equal to minus 3, okay, and x is equal to 3, we have to check the discontinuity, okay? So let's see, limit x tends to minus 3 minus f of x, that is equal to limit x tends to minus 3 minus, the value of x is very close to minus 3 and left of minus 3. See, where is the left of minus 3? That will be minus 4 point something, right? That is minus 4 point something. So f of x, what is f of x? So minus, that is less than minus 3. Less than minus 3 means the function is modulus x plus 3, or we can write minus x plus 3. Okay, it will be minus x plus 3. That is equal to, now substitute this value, x is equal to minus 3. So minus of minus 3, that is plus 3 plus 3 plus 3, 6. Okay. Next, let's find right hand limit. Limit x tends to 3 plus minus 3 plus f of x, that is equal to, here the values of x are very close to minus 3, okay, very close to minus 3 and right of minus 3, that is greater than minus 3. Greater than minus 3, the function is minus 2x, okay, minus 2x, okay, limit x tends to minus 3 plus minus 2x, here substitute minus 3, so you will get 6, right? So we have got left hand limit is equal to right hand limit. Now let's find the value of the function, that is f of minus 3, okay. F of minus 3 is equal to, here x is equal to minus 3. See, when x is equal to minus 3, the function is modulus x plus 3, right? The function is modulus x plus 3. So what is f of minus 3? Substitute, that is modulus minus 3 plus 3, that is equal to modulus minus 3 is 3. So 3 plus 3, 6. Here also we have got limit x tends to, no need to write, right? So here we can say, see, left hand limit that is equal to right hand limit that is equal to value of the function. Hence the function is continuous. Hence f of x is continuous at x is equal to minus 3. Okay. Next we have to check at x is equal to 3. Okay, at x is equal to 3, the function is continuous or not. So let's find. So here also we need to check the left hand limit and right hand limit. Okay. So left hand limit of the function, limit x tends to 3 minus, the value of x is close to 3 but less than 3. But less than 3, the function is minus 2x. Okay, f of x is equal to limit x tends to 3 minus f of x is minus 2x. Now here substitute x is equal to 3, you will get minus 6. Okay. Next, limit x tends to 3 plus f of x, that is equal to 3 plus means that is right of 3, that is greater than 3. So the function is 6x plus 2. So limit x tends to 3 plus 6x plus 2. Now substitute x is equal to 3. So 20. Okay. See here. We have got left hand limit not equal to right hand limit. Okay. Therefore, the limit x tends to 3. Limit x tends to 3. F of x does not exist. Hence, this function is not continuous at x is equal to 3. Okay. So it is not equal. Therefore, f of x is not continuous or discontinuous. Okay. Continuous at x is equal to 3. Okay. So, what is the point? At which point the function is not continuous? The function is discontinuous. At x is equal to 3, the function is discontinuous. Okay. Find all points of discontinuity of f where f is defined by f of x is equal to modulus x by x if x not equal to 0. F of x is equal to 0 if x is equal to 0. See, here we know that modulus x can be defined as modulus x is equal to minus x if x less than 0, right? Modulus x is equal to x if x greater than 0, right? Modulus x is equal to minus x when x less than 0, modulus x is equal to x if x greater than 0. So, this function can be redefined as f of x is equal to, here it is not mentioned x less than 0, when x less than 0, when x greater than 0, right? So here we can write f of x is equal to, see modulus x is equal to minus x when x less than 0, right? So therefore f of x is equal to minus x divided by x if x less than 0. Okay. Then and 0, function is 0 if x is equal to 0. Okay. Next, see, modulus x is equal to x if x greater than 0. Therefore, this can be written as modulus x is equal to plus x, right? Plus x divided by x if x greater than 0. Okay. So, this function can be redefined as minus x by x is minus 1 if x less than 0. F of x is equal to 0 if x is equal to 0. And f of x is equal to 1 if x greater than 0. Okay. Now, next here we can say, now let's check whether this function is continuous at which points and all. Okay. So here minus 1 function is equal to minus 1 if x less than 0. And when x greater than 0, the function is 1, constant function is continuous. So here we can write for x less than 0 and x greater than 0, the function f of x is continuous. Okay. Now we have to check the function is continuous at x is equal to 0 or not. Why? Because see here, it is x less than 0. See, when we take left hand limit and right hand limit, see, we know that left hand limit, that is left of 0 is nothing but that is negative values, that is less than 0. Okay, and right limit of right of 0 is nothing but that is positive. So here we have to check, okay, whether the function is continuous or not. Now at x is equal to 0, okay, at x is equal to 0. Now let's check left hand limit and right hand limit, okay. Limit x tends to 0 minus f of x, that is equal to limit x tends to 0 minus means less than 0, very close to 0, that is less than 0. So what is the function? F of x is equal to minus 1. So limit of minus 1, that is constant itself. So minus 1 itself. So next let's find right hand limit. Limit x tends to 0 plus f of x. That is equal to 0 plus means greater than 0. When x greater than 0, the function is 1. So limit x tends to 0 plus 1, that is equal to its limit is 1 itself. See, here we have got left hand limit not equal to right hand limit. Therefore, the limit does not exist. The function is not continuous at x is equal to 0. Okay. Here f of x is discontinuous at x is equal to 0. Okay, you can write left hand limit, that is limit x tends to 0 minus f of x not equal to limit x tends to 0 plus f of x. Hence f of x is discontinuous at x is equal to 0. Okay, that one we had to find. Okay, because all points of discontinuity, at which point the function is discontinuous. Okay, so at x is equal to 0, this function is discontinuous. Find all points of discontinuity of f, where f is defined by f of x is equal to x by modulus x if x less than 0, f of x is equal to minus 1 if x greater than or equal to 0. Here the function is x divided by modulus x if x less than 0. Here we know that modulus x is equal to minus x if x less than 0, when x less than 0, right? So if we here we can write x divided by minus x if x less than 0, that is minus 1. Okay, otherwise we can say in another way, for x less than 0, see, here we know that x is continuous function, right? Because x is a polynomial function and it is continuous. Modulus function, we have already proved that modulus function is a continuous function, right? So here it is quotient of quotient of two continuous function, it is continuous. Okay, so f of x is quotient of two continuous functions we know that if f and g are continuous functions, then f divided by g is also continuous, right? Hence f of x is continuous for x less than 0. Okay, now let's check at x is equal to 0. Okay, before that let's see, when x is greater than 0, what is the function? F of x is equal to minus 1, that's a constant function. Constant function is always continuous function. Okay, so f of x is equal to minus 1 when x is greater than 0. So here also we can write, for x greater than 0, f of x is continuous. Okay, f of x is continuous because when x is greater than 0, the function f of x is equal to minus 1 and it is continuous. Okay, then here next we have to check whether this function is continuous at x is equal to 0. Individually we have to check. Okay, so because our conditions are x less than 0, x greater than 0, different functions, right? Okay, we have to check. So here we need to find the left hand limit and right hand limit of the function. Limit x tends to 0 minus, okay, here now we are going to check whether this function is continuous or not at x is equal to 0. Limit x tends to 0 minus f of x is equal to limit x tends to 0 minus means less than 0. The function is x divided by modulus x, that is equal to, here see, when x less than 0, our definition modulus x is equal to minus x when x less than 0, right? That is the definition of the modulus x. It is x if x greater than 0. Okay. So here it is x values are less than 0. So modulus x value will be minus x, right? So it will be limit x tends to 0 minus x divided by minus x, right? That is equal to limit x tends to 0 minus 1. Okay, x divided by minus x, that is minus 1. So here the limit will be minus 1 itself. Okay, next, right hand limit. Limit x tends to 0 plus f of x, that is equal to limit x tends to 0 plus f of x. Okay, when x greater than 0, what is the function? When x greater than 0, the function is minus 1. Okay, so function is minus 1. So the value limit of minus 1 is minus 1 itself. Okay, here we have got left hand limit is equal to right hand limit. Next we will find the value of the function at x is equal to 0. Okay, that is f of 0. What is f of 0? When x is equal to 0. Okay, when x is equal to 0, the function is minus 1. At x is equal to 0, the function is minus 1. So f of 0 is minus 1. See, here we have got left hand limit, that is equal to right hand limit, that is equal to value of the function, that is minus 1. Okay, so here we can say this function is continuous at x is equal to 0. So this function f has no point of discontinuity. Okay, so here we write f of x is continuous at x is equal to 0. Hence, there is no point of discontinuity. Okay, no point of discontinuity means this function is continuous at all the points. Okay. Find the points of discontinuity of f, where f is defined by f of x is equal to x plus 1 if x is greater than or equal to 1, f of x is equal to x square plus 1 if x less than 1. Very simple. See here, if x greater than 1, function is x plus 1, x less than 1, x square plus 1. Here for x less than 1 and x greater than 1, the function is polynomial function. Okay, therefore it is continuous at x less than 1 and x greater than 1. Okay, so we write for x less than 1 and x greater than 1, f of x is polynomial function. Therefore f of x is continuous at x less than 1 and x greater than 1. Okay. Now here next we have to check whether this function is continuous at x is equal to 1 or not. Okay. So for that we need to find left hand limit and right hand limit, because the conditions are x greater than or equal to 1, x less than 1, right? So here we need to check the left hand limit and right hand limit. So limit x tends to 1 minus f of x, that is equal to limit x tends to 1 minus f of x is, see, 1 minus means less than 1. Okay, x is less than 1. See, when x is less than 1, the function is x square plus 1, that is equal to, substitute x is equal to 1. So 1 plus 1 is 2. Next, let's find right hand limit of the function, that is limit x tends to 1. Okay, x tends to 1 plus f of x, that is equal to limit x tends to 1 plus, here 1 plus, that is greater than 1. When x is greater than 1, the function is x plus 1. So x plus 1. Now substitute x is equal to 1, 2. Limit of x plus 1, that is 2. So here we have got left hand limit is equal to right hand limit, right? Next we need to find, according to the definition of the continuous function, we have to prove that left hand limit that is equal to right hand limit that should be equal to value of the function, okay, at x is equal to 1. So here what is f of 1? F of 1 is when x is equal to 1, at x is equal to 1, what is the function? X plus 1, okay. At x is equal to 1, because here it is given when x greater than or equal to 1, right? So when x is equal to 1, the function is x plus 1. At x is equal to 1, f of x is equal to x plus 1. So what is f of 1? Substitute x is equal to 1. That is 1 plus 1, 2. Okay. Now here, see, we have got left hand limit that is equal to right hand limit that is equal to value of the function. Okay. That is limit x tends to 1 minus f of x, that is equal to limit x tends to 1 plus f of x, that is equal to f of 1. Therefore, the function is continuous at x is equal to 1. Therefore, f of x is continuous at x is equal to 1. This function is continuous at x is equal to 1, x less than 1, x greater than 1. Okay, at x less than 1, at x greater than 1. So therefore, this f has no point of discontinuity. Okay, so this function is continuous at all the points. So f of x has no point of discontinuity. That's all. Here also we have to find at what point the given function is discontinuous. Okay. So here also all are similar questions, right? So f of x is equal to x cube minus 3 if x less than or equal to 2. F of x is equal to x plus x square plus 1 if x greater than 2. Okay. So here also we can say for x less than 2 and x greater than 2, function is polynomial function, right? X cube minus 3, x square plus 1 are polynomial functions, and every polynomial function is a continuous function. Therefore, f of x is continuous at x less than 2 and x greater than 2, right? For x less than 2 and x greater than 2, f of x is polynomial function. F of x is polynomial function. Therefore f of x is continuous. F of x is continuous at x less than 2 and x greater than 2. Okay. Then next we have to check at x is equal to 2. Okay. That is at x is equal to 2 whether it is continuous or not. Okay. So for that we have to, here also we need to find the left hand limit and right hand limit of the function at x is equal to 2. Okay, at x is equal to 2. So here limit x tends to 2 minus f of x, that is equal to limit x tends to 2 minus f of x. X tends to 2 minus means x less than 2. When x less than 2, the function is x cube minus 3, that is equal to, substitute x is equal to 2. Okay, not minus 2. 2 minus means less than 2. Okay, left of 2. So 2 cube is 8. 8 minus 3, 5. Next, let's find right hand limit. X tends to 2 plus f of x is equal to, x tends to 2 plus means greater than 2. When x is greater than 2, function is x square plus 1. So limit x tends to 2 plus f of x is x square plus 1. X square plus 1. Now here also substitute x is equal to 2. That is 2 square plus 1, 5. Okay. So here also we have got left hand limit is equal to right hand limit. Next we need to find value of the function, that is f of 2. When at x is equal to 2, what is function? What is the function? Function is f of x is equal to x cube minus 3. X cube minus 3, okay? Because it is given x less than or equal to 2, the function is x cube minus 3, okay? So at x is equal to 2, f of x is equal to x cube minus 3. So what is f of 2? F of 2, replace x to 2, right? So substitute x is equal to 2. So 2 cube, 8 minus 3 is 5. So f of 2 is also 5. So according to the definition of the continuous function, this function is continuous at x is equal to 2, because we have got left hand limit, right hand limit, that is equal to value of the function. Limit x tends to 2 minus f of x, that is equal to limit x tends to 2 plus f of x, that is equal to f of 2. Hence the function is, hence f of x is continuous at x is equal to 2. Therefore this function is continuous at x is equal to 2, x less than 2 and x greater than 2. So this function is continuous at all the points, right? Therefore this function has no point of discontinuity, okay? Hence f has no point of discontinuity. Here also we have to find at what point the given function is discontinuous. Okay. So the given function is f of x is equal to x raised to 10 minus 1 if x less than or equal to 1. F of x is equal to x square if x greater than 1. Right. So here also same thing, similar questions. So here also we can say for x less than 1 and for x greater than 1, the function is polynomial function, therefore it is continuous. And at x is equal to 1, we have to check the continuity. Okay. So for x less than 1 and x greater than 1, f of x is polynomial function, right? It is polynomial, x raised to 10 minus 1, x square are polynomial function. Is polynomial function. Therefore, f of x is continuous at x less than 1 and x greater than 1. Okay, next we have to check the continuity at x is equal to 1. At x is equal to 1. Okay, so here also we need to check the left hand limit and right hand limit. The conditions are x less than or equal to 1, x greater than 1. Okay, so here limit x tends to 1 minus f of x, that is equal to limit x tends to 1 minus f of x, that is when x less than 1, the function is x raised to 10 minus 1, that is equal to, substitute x is equal to 1, so 1 minus 1, 0, right? Next, right hand limit x tends to 1 plus f of x is equal to limit x tends to 1 plus, that is when x greater than 1, 1 plus means greater than 1, when x greater than 1, the function is x square, so substitute x is equal to 1, so the value is 1. See here itself we have got left hand limit is not equal to right hand limit, therefore f of x is not continuous at x is equal to 1. Okay, that is at x is equal to 1, given function is discontinuous. Okay, at x is equal to 1, f of x is discontinuous. Is the function defined by f of x is equal to x plus y if x is less than or equal to 1, f of x is equal to x minus y if x is greater than 1, a continuous function? See, if a function is continuous function, if the function should be continuous at all the points, right? If a function is continuous at all the points, then we say given function is a continuous function. So here also we have to check the given function is continuous at all the points or not. Okay. So first of all, see here, when x less than 1 and x greater than 1, the function is polynomial function and it is continuous. Okay. So the function is continuous at x less than 1 and x greater than 1. Next we have to check whether this function is continuous at x is equal to 1. Okay. So here, see, all are similar questions, right? For x less than 1 and x greater than 1, f of x is polynomial function therefore f of x is continuous at x less than 1 and x greater than 1. Next we have to check at x is equal to 1. The continuity at x is equal to 1. If it is continuous at x is equal to 1 also, then we say the given function is continuous function. Okay. So let's check at x is equal to 1. Okay. So here also we need to check left hand limit and right hand limit. Limit x tends to 1 minus f of x is equal to limit x tends to 1 minus, that is when x less than 1, the function is x plus 5, substitute x is equal to 1, limit is 6. So next right hand limit x tends to 1 plus f of x is equal to limit x tends to 1 plus f of x is x minus 5, substitute x is equal to 1, so it is minus 4. 1 minus 5 is minus 4. So next, see here, we have got left hand limit is not equal to right hand limit. That means this function is not continuous at x is equal to 1. Okay, f of x is discontinuous at x is equal to 1. Therefore, see, this function is continuous at x less than 1 and x greater than 1, but not continuous at x is equal to 1. Okay, that means this function is not continuous at all the points. Okay, so here that means there is a point, right, for discontinuity. So therefore we can say this function is not a continuous function. Okay, hence f of x is not a continuous function. Okay, because a function is continuous, when a function is continuous, if the function is continuous at all the points. Okay, if the function is continuous at all the points, then we say given function is a continuous function. But it is not a continuous function because this function is not continuous at x is equal to 1. Okay.